The summer of 2021, temperatures in Siberia shattered records, and what happened next permanently changed how we understand fire. On the 19th of July, 2021, NASA satellites detected a single wildfire complex larger than all other active fires on Earth combined at that moment. 18 million hectares reduced to ash, roughly the size of Missouri and Arkansas combined, erased from the map in a single fire season. This was the worst recorded wildfire season in Russian history, and it happened in the coldest permanently inhabited place on Earth. What truly alarmed scientists was not the fire itself, but what lay beneath the ground and was beginning to wake alongside it. The story of this fire begins not with a spark or a lightning strike, but with thousands of years of frozen organic matter slowly thawing open. Siberia is not a dense tropical jungle with towering canopies. It is a land of low, sparse conifers rooted in permafrost, dozens of meters deep, that has been frozen for tens of thousands of years. The Sakha Republic, also known as Yakutia, covers 1/5 of all Russian territory, but is home to fewer than 1 million people. In January, temperatures here can plunge to -60 degrees Celsius, yet local residents still drive to market and send children to school as if it were ordinary. But in the summer of 2021, that very extreme cold betrayed this land in a way no one had anticipated. Summer temperatures that year in Yakutia ran 8 degrees Celsius above the historical average, a figure climate scientists describe as categorically anomalous for any region on Earth. The moss and peat layers dried to perfect fuel, and the previous winter had left far less snowpack than usual across eastern Siberia, meaning the land entered summer already parched. In early June, the first small fires appeared in western Yakutia, and Russian authorities initially classified them as natural fires not requiring active suppression. This was long-standing Russian policy, allowing natural fires to burn in remote, uninhabited regions because the cost of suppression was judged too high relative to the economic value of the land. But July that year was unlike any July in the recorded history of this region, and the small fires began merging in ways no forecast model had predicted. Dry winds from an anomalously positioned high-pressure system pushed the fires northward toward old-growth forest stands that had not experienced fire in several centuries. This is the moment climate scientists call a tipping cascade, when a series of environmental factors simultaneously breach the threshold the ecosystem can absorb. On the 19th of July, NASA's MODIS satellite recorded fire area exceeding 10 million hectares in a single daily measurement pass, an absolute record in the history of satellite fire monitoring. Try to understand 18 million hectares this way. It is larger than the entire country of Germany, and it burned in a single summer. The fire front advanced at an average of 4 to 6 kilometers per hour in wind, and on certain days, it moved more than twice that speed. Fire in Siberia does not only burn at the surface, it penetrates 1 to 2 meters deep into the peat layer underground and smolders for weeks and months after the surface flame has gone. These are what researchers call zombie fires, smoldering beneath the snowpack through winter and reigniting the following spring, as if they had never been extinguished. During July and August, smoke from Siberia crossed Alaska, traversed Canada, and was detected above the eastern United States more than 8,000 kilometers away. Consider what it means when a fire grows large enough to generate its own weather system and begins altering atmospheric conditions, thousands of kilometers from its origin point. The fire generated pyrocumulonimbus clouds, thunderstorm systems born directly from the heat of the fire, powerful enough to produce lightning strikes that ignited new fires across the surrounding region. This was no longer simply a wildfire. This was a self-sustaining weather system feeding itself with its own flames. The city of Yakutsk, the capital of the Sakha Republic, with nearly 300,000 residents, was submerged in smoke for weeks continuously throughout July and August. Air quality index readings in Yakutsk during peak days exceeded World Health Organization danger thresholds by a factor of 10, the equivalent of smoking 30 cigarettes per day simply by breathing outdoors. Hospitals in Yakutsk reported respiratory admissions 3 times higher than seasonal norms, and children under 12 were advised not to go outdoors for the entire month of August. More than 140 small settlements scattered across the Yakutia taiga faced direct fire threats, many accessible only by riverboat or helicopter and with no road connection to the outside world. In those villages, many indigenous Yakut families had lived and hunted this land for hundreds of years, and the forest was not simply an economic resource, but the foundation of their identity. When the fire closed in, Russian firefighting teams faced a choice: prioritize protecting human settlements or attempt to contain a fire that had already exceeded the capacity of any ground-based resource. Russia deployed more than 5,000 firefighters, dozens of aerial tanker aircraft, and heavy military equipment throughout the fire season. But measured against the scale of the fire, these resources were negligible. Picture this differently. If you assembled the combined firefighting capacity of the 50 largest nations on Earth, they would still be insufficient against a fire generating its own wind systems and its own lightning. Beneath the fire, a second process was unfolding, and this is the one that kept climate scientists awake at 3 in the morning. Permafrost, the permanently frozen ground layer, covers more than 65% of Russia's land area and contains an amount of organic carbon roughly double the total CO2 currently in Earth's entire atmosphere. When fire strips the moss and tree cover above, the natural insulating blanket protecting the permafrost disappears, and the summer sun begins attacking the frozen layer directly. Thawing permafrost releases methane and CO2 locked away for thousands of years, and this is the feedback loop scientists fear most. Warming thaws the permafrost, thawing releases greenhouse gases, those gases drive further warming. In the single fire season of 2021, Siberian wildfires released an estimated 800 million metric tons of CO2 into the atmosphere, exceeding Germany's entire annual carbon emissions. 800 million metric tons of carbon, the same quantity of greenhouse gas produced in a full year by all of Germany with its 84 million people and its continent leading industry, released by Siberia in a single summer. While the fires burned on the ground, the European Copernicus Atmosphere Monitoring Service tracked every smoke filament from space and issued warnings that these were the highest wildfire emission levels since modern measurement records began. Smoke from Siberia crossed the Arctic and was detected in the stratosphere above North America, where black carbon particles reduced solar reflectivity and contributed to additional Arctic ice melt. When black smoke particles settle onto white ice surfaces, they absorb heat rather than reflecting it as clean ice does, and this process accelerated Arctic ice melt beyond the projections of every climate model in use at the time. Villages in the immediate danger zone began evacuating in late July, and for many families, this was the first time in their lives they had ever left their ancestral land. Ground firefighting crews worked in ambient air temperatures exceeding 35 degrees Celsius in air so smoke-laden that breathing without protective masks was impossible even in locations kilometers from the fire front. The Il-76 aerial tanker aircraft flew multiple sorties per day, but each water and retardant drop only slowed the fire for minutes before it overran the line and continued advancing. By early August, one fire front advanced to within 10 kilometers of the Yakutsk city boundary, and for the first time, Russian authorities began examining contingency plans for partial evacuation of the regional capital. This was no longer only an ecological crisis, it was a potential urban emergency in one of Earth's most isolated cities, a city with no highway connection to the outside world during summer. Rain finally arrived in mid-August, not through human intervention, but because the natural weather system eventually shifted, drawing Pacific moisture deep into the continental interior. But by that point, 18 million hectares were already gone, and no amount of rainfall could change that number or what it meant for the ecosystem that had been there. When the fires retreated and the smoke cleared, what scientists saw in satellite imagery and monitoring flights left them without adequate language to describe the scale of what had happened. 18 million hectares of taiga is not simply trees, it is an ecosystem housing thousands of plant and animal species, the water source for dozens of major river systems, and the climate regulation mechanism for the entire Arctic zone. Wildlife species, including wild Siberian reindeer, brown bears, and wolves, were displaced from their traditional territories, moving into unburned zones and creating cascading ecological pressure across adjacent ecosystems. The permafrost beneath the burn zone lost its insulating cover and began thawing faster than at any previously recorded rate. And once permafrost thaws to sufficient depth, the process cannot be reversed on any timescale meaningful to humans. Post-disaster studies found permafrost thaw rates in heavily burned zones running 3 to 5 times higher than in adjacent intact forest areas, an effect projected to persist for, at minimum, several decades. Evacuated villages gradually returned, but many residents came back to find their homes standing, while the forest they depended on for hunting, gathering, and grazing had completely disappeared. For Indigenous Yakut communities whose livelihoods depended directly on the forest, the winter of 2021-22 was the most difficult in the memory of multiple generations. Direct economic damage from the 2021 fire season was estimated at several billion US, counting only the value of lost timber and forest resources before factoring in healthcare costs and infrastructure impacts. But no economic figure can measure the true cost of losing an irreplaceable component of the global climate regulation system, because that cost is not paid in money, but in the future. Recovering a mature taiga forest under Siberian conditions requires 100 to 150 years under a stable climate. But the climate is no longer stable. Climate models project that if current warming trends continue, Siberian wildfire seasons will become both more frequent and more intense before any young forest has sufficient time to mature and provide meaningful protection. This is the spiral scientists call forest-to-grassland transition, when fire recurs so frequently that forest cannot regenerate and the ecosystem permanently converts to treeless steppe. The story of the 2021 fire season did not end when the flames went out. It simply moved into a slower chapter, one longer and more consequential than the fire season itself. The disaster forced the Russian government to fundamentally reassess wildfire management policies maintained for decades, particularly the non-intervention policy for fires remote from populated areas. In 2022, Russia expanded mandatory fire suppression zones by millions of hectares, meaning fires in areas previously classified as non-intervention zones would now require immediate active response. Russia's satellite wildfire monitoring system was significantly upgraded, integrating both optical and radar satellite data to enable real-time tracking even through dense cloud cover that previously blinded optical sensors. But technology and policy are only part of the lesson, because the real question is not how to extinguish these fires faster, but why they are growing larger and more frequent with each passing decade. Siberia is warming at 4 times the global average rate, a phenomenon the IPCC describes as Arctic amplification and identifies as one of the most alarming signals in the entire Earth climate system. Research published following the 2021 disaster found the probability of a wildfire season of comparable scale occurring in Siberia had increased by at least 500% relative to pre-industrial baseline conditions. This means what happened in 2021, what we would once have called a once-in-a-century event, now has a realistic probability of recurring within a 20-year window. The Siberian taiga is not the only boreal forest facing this trajectory. Canada lost nearly 18 million hectares in 2023, and Alaska records increasingly severe fire seasons with each passing decade. Scientists are now closely monitoring the West Siberian lowlands, a vast peatland region equivalent in area to the entire Mekong Delta multiplied 15 times over, containing enormous reserves of carbon not yet released. If those peatlands were to burn at a scale comparable to Yakutia in 2021, the carbon release would drive climate changes beyond the projections of any current forecasting model. This is why climate scientists refer to the 2021 Siberian fires as a sentinel event, a warning signal indicating that the system is approaching thresholds from which there may be no return. But the story of summer 2021 is not only a story of coming catastrophe, it is also the story of indigenous knowledge that recognized these changes long before Western science could measure them. Indigenous Yakut communities observed shorter winters, earlier snowmelt, and shallow lakes, gradually disappearing across several decades before any formal scientific study confirmed these observations. Modern climate science and indigenous knowledge are learning to listen to each other, and Siberia is the place where that lesson is most urgently unfolding. What happened in the most remote and coldest inhabited territory on Earth during that summer was not a problem belonging to Russia or to Siberia alone. The smoke from that fire was in air you breathed. The carbon from that fire entered the atmosphere in which all of us live, and the warmth that thawed, that permafrost, is adding to a feedback loop from which none of us are exempt. Scientists from Russia, the United States, Europe, and Japan jointly analyzed data from the 2021 fire season and published collaborative research on climate consequences in the years that followed. Those studies changed how global climate models calculate wildfire contributions to carbon emissions, meaning climate projections from that point forward all required revision in a more unfavorable direction. The boreal taiga forest stretches from Canada across Siberia to Scandinavia, covering roughly 30% of all forest land on Earth and constituting the largest carbon reservoir in any terrestrial ecosystem. If the Siberian taiga were to transition from a net carbon sink to a net carbon source through increasingly frequent fire, it would represent one of the most significant inflection points in the history of the modern climate system. This is not a speculative scenario or extreme catastrophe narrative. This is the current trajectory of the system in the absence of fundamental changes to global temperature trends. But the story of summer 2021 in Siberia does not end there, because the most instructive part may be what did not burn, the forest areas that survived, and the reasons why they did. Mature forests, stands with intact, moist moss layers beneath them, areas near water sources, and forests on better drained, elevated ground, all demonstrated markedly higher resistance against fire penetration. This suggests that protecting forest soil moisture through watershed management and limiting timber extraction may be among the most practical long-term tools against extreme wildfire in a warming climate. Indigenous communities in Yakutia have long practiced small-scale seasonal controlled burning to create buffer zones and reduce fuel loads, a technique modern fire science is now studying with serious renewed attention. The summer of 2021 in Siberia left an indelible mark in the planet's climate record, a thin layer of black carbon in Arctic ice cores that will persist for centuries as a geological trace of an extraordinary summer. That ice layer will lie there, recording this moment for anyone curious enough to read it hundreds of years from now, a message to the future from a summer the world was not yet prepared to face. The forests are recovering slowly, young larch seedlings rising from the ash across Yakutia, and this is a process that has occurred thousands of times in the history of this land. But this time, the question ecologists are asking is whether those young trees will have sufficient time to reach maturity before the next fire arrives, or whether they will burn again while still saplings. This question matters not only to Siberia, but to Earth's entire climate system, because its answer will determine whether the last great green lung of the polar region remains a lung at all. Summer 2021 was not the end point of a story. It was the midpoint of an ongoing one whose final chapter no one yet knows how to write. In the summer of 2023, Canada burned 18 million hectares, a number remarkably similar to Siberia 2 years earlier, and no serious researcher calls that a coincidence any longer. Scientists tracking both events understood they were not witnessing two isolated disasters, but a global system in the process of changing state. That system connects all of us, whether we sit in a city far from any forest, whether we see the smoke or not, whether we feel the heat or not, because the atmosphere does not honor borders. The Yakut residents who evacuated in July 2021 returned to their villages, rebuilt what could be rebuilt, and are still living on the land their ancestors inhabited for centuries. They live there because it is their home, and because abandoning ancestral land is not a choice they are willing to accept, regardless of how many times disaster arrives. Their resilience is another lesson that some are left behind, that even when systems larger than any human agency exceed all control, people retain the choice of how they stand within them. Policymakers from more than 20 countries cited the 2021 Siberian fire season in climate and disaster risk management documents published in the years that followed. International boreal forest protection funds received unprecedented attention and financial commitments within 2 years of the disaster, as the world finally saw in satellite images what scientists had been describing in words for decades. But commitment and action are two different things, and scientists continue watching each Siberian summer with an anxiety they no longer try to conceal. Every June, as temperatures rise and the snowpack begins receding, wildfire monitoring stations across Siberia begin another season of vigilance whose end no one can predict. The only certainty is that Siberian forests will continue to burn. The question is only how much, and whether what remains will be sufficient to prevent the climate feedback loop from crossing the threshold beyond which no human intervention has any effect. The Siberian taiga has stood here for thousands of years before humanity began measuring Earth's temperature, and it has witnessed countless winters and summers come and go across the centuries. But no summer in the modern measurement record of this region resembled the summer of 2021, and that is not a coincidence. It is the result of decades of accumulation, of energy and emissions decisions made thousands of kilometers away, and of a climate system responding in precisely the way its physics dictates it must. Permafrost is still thawing. Underground fires are still burning beneath the snow in parts of Yakutia right now, and methane is still rising from new lakes, forming above collapsing ground. The story of that summer in Siberia is not in the past. It is still occurring, only slower and deeper below the ground than any satellite screen can display. And there, in the darkness beneath the frozen Siberian ground, the carbon archive of tens of thousands of years is slowly being unlocked, centimeter by centimeter, with each passing summer. The summer of 2021, satellites saw 18 million hectares of fire and recorded it in the human archive as an unprecedented record. But what the record does not contain is the question that record poses to us, whether we treat this as a singular disaster and move on, or as a signal that the planet is communicating something more important than any measurement. 18 million hectares. That is the number of a single summer, and it will remain in Earth's climate record for hundreds of years after everyone who witnessed it is gone. And in the ash of Yakutia, young larch trees are still growing, slowly and patiently, knowing nothing of records or disasters, doing only what they have always done, which is to grow.